intelligence, transforming the next generation intelligence system. So mainly we are going to discuss about the quantum computing, and if there is time permit, we'll discuss about the artificial intelligence and the next generations of the intelligence system. First, so the objectives of this our main FDP is the quantum computing fundamentals, the quantum computing fundamentals, the classic versus the quantum computing, the qubits for the superposition in entanglement, and the quantum gates and the algorithm, IBM quantum, the Google quantum AI, Azure quantum, and some artificial intelligence, ML, and the deep learning, the comparison between those three, and generative AI and the large language model, and the QAM, that is quantum machine learning, AI quantum integrated architecture, the applications related with this quantum computing, the industry oriented, the industry that's the 5.0, and the ethical AI and the responsible quantum computing, research challenge and the future trend, and the references of question and answers like this. So mainly we are going to discuss about. So mainly we are going to discuss about these quantum computing fundamentals, the classic and the quantum computing qubit gates, and the quantum Google quantum AI. Okay. So introduction to quantum computing. This quantum computing is a revolutionary computing paradigm that harnesses the principles of quantum mechanics to process the information in such a way that a classical computer can. This quantum computer, it gives us a more revolutionary computing paradigm, which takes the information that normal computer which cannot do with this quantum computing can do. So unlike this classical computer which uses the zeros and one, normally our computer uses the zeros and one. This quantum computer uses a qubit. Qubit means it is also the combination of zeros, one, or it can be the both. So it can use the zeros, one, or both. That is a qubit, which is existing the multiple state simultaneously through the superposition. We are having the different types of terminologies in this quantum computer, like the qubit, superposition, entanglement, and quantum interfaces. In the next slides, we are going to discuss about all these qubits, superposition, entanglement, and quantum interface. These combined with this entanglement and the quantum interface, the quantum computers can solve the certain complex problems exponentially faster than the today most powerful supercomputer. By using this entanglement and the quantum interference, one can easily solve the complex problems. Okay, more complex problem, exponential problems, very super, which is very much very powerful than the supercomputers. This quantum computing has the potential to transform the fields such as AI, cryptography, drug discovery, financial modeling, then the climate simulation, optimization, and material science, which is a very much promising technology in the 21st century. This quantum computing, it is mainly used in the 21st century in the some professionals like AI, cryptography, drug discovery, financial modeling, climate simulations, where this quantum computing uses very much. Then, so if you see here, the previously 2500 BC, we use this abacus like that for computing. In the 20th century, we use these processors. And in this 21st century, now we are using this quantum, just the light or the light which can do all the things. So, if you see here, the previously 2500 BC, we use this abacus like that for computing. In the 20th century, we use this processors. And in this 21st century, now we are using this quantum, just the light or the light which can do all the things. So, if you see here, the previously 2500 BC, we use this abacus like that for computing. In the 20th century, now we are using this quantum, just the light or the light which can do all the things. So understanding the technologies, here the bits, and whatever we are using the now the bits, so that is zeros or ones. So either